In today's video, we are going to talk about applications of quantum dots outside of quantum communication in real life kind of setups. And the company that is bringing those to us is called Quantum Solutions. If that sounds interesting to you, then stay tuned for today's video as we dive right into it. But before that, as always, make sure to stay hydrated, get yourself something to drink as we dive into the world of quantum dots. So, here we are on the website. It says Quantum Solutions up here. Invisible intelligence, quantum dot imaging for beyond visible data. And in the background, we see some drones flying around. And then we see this type of 3D architecture with some colorful overlay here. And we see solar cells. Now, we will learn a little bit more about these applications. But just to say, what is interesting about that is the quantum dots, and we've talked about them before. If you haven't heard about quantum dots, make sure to check out the Hidden Quantum Champions playlist. There are other videos also about companies that are working in the field of quantum dots. Quantum dots can generate certain type of wavelength. Wavelength is kind of the color of the light that you're looking at. So there's visible wavelength, which is let's say from red to blue, but there's also, or violet, there's also light outside that spectrum. So there's the infrared spectrum on the, let's say, lower frequency or higher wavelength side. And on the other side, on the shorter wavelength and higher frequency side, you have the ultraviolet all the way up to extreme ultraviolet, the stuff that is going into these ASML machines that we've talked before, all the way up to X-ray, what you know from your doctor when they're looking at your bones. And here, these quantum dots, they can be tuned in such a way that they can identify or that they are set to exactly the frequency that is relevant for water. So water has, of course, an absorption spectrum. So, for example, if you're looking at your window, you can see through, right? That's because it doesn't absorb any light in this range that you are considering the visible range. However, for example, for ultraviolet radiation, the window is actually not transparent because the radiation is getting blocked by it. So let's say for a lot of windows, and of course not 100%, but let's say that's kind of roughly what it looks like. On the other hand, if you, for example, have a thermal camera that can detect, let's say, infrared radiation, you can maybe even see through a wall because the wall might still, let's say, radiate the heat of that person that is standing behind it. So you can, with that camera, see through a wall where optically you can't see anything. Now, for the quantum dots here, Quantum Solutions is tuning them in such a way that they are exactly aligned with the absorption spectrum, for example, of water. And that way they can see how the hydration, for example, in these fields here looks like. So you can see certain areas are blue, others are red. So that way they can know, is there water present or is it kind of drying out, which is, of course, relevant for agricultural applications. And if you can connect the device to a drone, you can really locally map. You can fly around and locally probe this. Now, the other thing here, that's the other one that's very interesting, is on solar cells. So we are seeing those solar cells spreading across, right? So they're going on roofs of industry buildings, but even if I sometimes drive through Germany, I see that there are fields which are covered with those, let's say, photovoltaic systems. And of course, you want to make sure that they can operate efficiently. And for that, you need to know, for example, if some of those are damaged. And you can't really see it from the outside. But again, if you have a certain spectrum of visibility, you can actually map this. And this is exactly what you see in the other applications. And we will learn more about that as, of course, we go through the company's website. So what are the products that they have? The products are cameras, payloads, and materials. And I guess we will learn a little bit more because if I look at it, it says Q-Fly, Q-Cam, so that's probably the cameras, and then the Q-Dots are on the material side. Below that, we see the news section here. I'm recording this video beginning of 2026. We see here end of 2025 is the last news. So I would say pretty much up to date. And it says Quantum Solutions debuts real-time water mapping payload at SPI Future Sensing Technologies. Besides that, this company also comes with a lot of customers and partners already. So just to kind of zoom out before I now go through these, I'm always trying to kind of organize a little bit in this quantum technologies setup. So here we are not looking at quantum computers most probably, but it's interesting in terms of quantum sensors. So having light sources that can create specific light so you can build a sensor with it. And then also we might be interested, it might be interesting in terms of communication, quantum communication, to have quantum dots as light sources. We've seen this with previous companies. Now looking at this map here of partners and also customers, we see exactly that. So we see, of course, there are partners from the universities and research field, like you see MIT here, of course, Los Alamos Labs in the US, but you also see Oxford from the UK, where also the company is from. You see the Toronto University here, so Notre Dame, so all across the let's say Western hemisphere, and probably also, if I look here, that also goes into the east. So you see Tokyo University, Busan, so you also see that there is Korea in there. So they're collaborating across the globe with different universities, Riken in Japan. But, and that's also interesting, you see giants in the space of semiconductors like iMac or Sony in here. You see Panasonic as probably, let's say, a little bit more higher level tech company, but you also see Merck in here, which is of course very interesting because they are more on the chemical side, on the pharmaceutical side, maybe even. You see BASF down here, also very much on the chemical side. So it's across the spectrum of those. And then you also see drone company in here, of course, because if you attach it to a drone, it makes sense to work with a drone company as well. And there are other ones in here as well. You also can already see testimonials. So you see here, product director from Embarion in the UK says Quantum Solution PBS quantum dots are high quality and purity materials with excellent optical and electronic properties. We have requested the materials be supplied in custom solvents, and Quantum Solutions has been extremely helpful in meeting our needs in this respect. We have found the materials perform well in our optoelectronic sensor devices with good batch-to-batch reliability. So batch-to-batch reliability means, of course, when you order again, or if it's produced in multiple batches. This is a semiconductor type of processing, so you always produce in wafer batches. Let's say, the comparison between those shows that they are quite equal, which is not always necessarily set, especially when it comes to these, let's say, more earlier stage technologies where you might not work on high production kind of setups, but more like on a research type of setup, right? We can also see other ones here. I'm not going to go through all of the details. iMac, Riken, universities, different universities. And then down here, we see the block, and that one we are going to check out as well a little later to understand a bit better what applications, real-world applications, this is kind of catering to already today. Now, let's quickly check out the Q-Fly. So see beyond the visible, quantum dot imaging for beyond visible data. Map water, inspect solar, so NDMI, on demand for real-time moisture intelligence. That's what I was trying to explain before. And then aerial electroluminescence with AI fault detection. So here you see it. This is what it looks like. If you're looking at the right spectrum, you can see the damage on the different cells up here. That's what it looks like when you just look at it. So you can see with this additional range you can see better. And here you see kind of the whole solution. So it includes, I guess, the light source. There's also a camera here, and it comes on a gimbal that you can attach to a drone. So, or maybe also an industrial setup. So it says plug and play SWIR payloads for research and exploration. Okay, let's move quickly. Sorry, I think there's more down here. So it says explore. So I guess here we can learn a little bit more. The first DJI ready quantum dot SWIR camera, plug and play compatibility with DJI Matrix RTK, providing real-time video streaming control and configuration directly from the DJI remote controller. So very exciting. I'm not going to click on the video, but yeah, it's kind of really like moving into a solution here already, right? This is not just some research lab type of setup. And there is the 3-channel one, so SWIR plus RGB plus thermal imaging, built for exploration without limits. The 3-channel offers SWIR, RGB and thermal imaging, see-through haze, smoke and challenging conditions. I can imagine that this is interesting for multiple different applications. We've seen the fields before, but probably also for kind of defense setups. They will probably also be interested, because the more channels you add to your camera, the more intelligence you can of course also collect, right? And then there's a 2-channel version with RGB and SWIR. Sensitive to key wavelengths, used in NDVI, NDMI, and mineral indices. And then it's plug and play, quantum dot technology. So this is the SWIR. We will learn a little bit more about that. And adaptable to any mission. So you can also see the long wavelength infrared, LWIR, is available as well. See beyond the visible. So SWIR helps you to see through fog, smoke, and low visibility conditions. There is an example up here as well. So you can see, well, maybe you cannot really see much in the RGB spectrum, but once you change the spectrum in the thermal, you can see something, and then I guess, yeah, in the IR spectrum you see something. Asset inspection, so you see some lines, probably water lines running across here. And then there's also remote sensing as well. And then, yeah, these are the applications that we've seen before, right? So there's the solar part, so diagnostics of solar cells. And there you can really see the cracks, which you can't really see on the pure heat image. So that's kind of helping for remote inspection, I assume. And then they even have an AI on top, which helps you to label those misfunctioning cells and collect insights. So here you see anomaly type micro cracks, and then it helps you to identify the systems that need to be replaced, that are not working well. But on the other hand, there's also the water side, and there's also a lot of applications on that one. Oh, maybe I clicked something. Let me try again. Now it works, probably on my side. So QFly, map water on demand, and here you can see what we've seen before, right? So there are fields, and you can see that you can really measure high water content versus low one. So QFly water turns invisible moisture variation into actionable intelligence. The dual band quantum dot payload computes a normalized difference moisture index, NDMI, in real time, generating a live colored coded moisture map as you fly. NDMI is the standard for measuring water in vegetation and soil, but satellite NDMI is trapped by fixed orbits, cloud interference, and 20-meter resolution floor. And that's also maybe important to mention, right? So there are satellites that can do that. However, and that's always the thing, right? So a satellite is kind of flying across the planet. They are usually not geostationary, so they are like moving around, and you are kind of bound by the trajectory. So you have to have a satellite that actually has a trajectory where your property that you want to see is in its visual field, and it might be rotating, so you might not get a live image every 2 minutes, but maybe only every 5 hours. Depends on the trajectory that the satellite is on. It also depends on the resolution, and of course, if it's cloudy, you cannot really see anything, right? And that's kind of what is explained here. The idea, the proposal is you take a drone, you get much more highly accurate data. You get it when you need it because you're flying with the drone, and you don't have any issues with clouds, of course. And it's interesting, or the use cases are to spot water deficiencies, so kind of making sure that everything is properly watered, and then protect your yield on the growth, right? But there's also other stuff here like expose leaks, optimize operations, identify uneven irrigation, and then you get the different cases here. So vineyards are of course a premium case because vineyards can usually create quite a, let's say, high margin yield. If you have very expensive wine, you can easily lose millions by kind of not watering your plants correctly. But there are also other ones like nuts that are, I think, growing quite slow. And there's also, let's say, more architectural ones like rooftops. Want to make sure that there's not water standing here on this rooftop for a long time. So maybe if one of these drainage pipes is clogged, then the water might sit on here for a long time until at some point there's a leak. So you might want to scan for that. And then of course infrastructure. And even archaeology is mentioned here. There are different versions as it seems. So there's a starter version, a pro version, and an enterprise version. In the starter version, you get a Qfly water payload, real-time NDMI during flight, up to 120 hectares processed, high-resolution orthomosaics and GPS accuracy. So it seems like this is as a service kind of approach, right? So here you get more field and you get more detailed reporting and data within 48 hours. And then on the enterprise level, I guess unlimited data, also 48 hours, and then priority processing and support. So sounds to me like you can find providers here. So they have an ecosystem of providers that operate these drones for you, and you can find them if you go here via their website. There's the QCam. I guess that's kind of clear what this is, right? So there you have the camera, the lenses, and the filters that you need to set things up. You can also see the price range here, not for the camera. You need to request that quote. And then there's the underlying technology, right? The quantum dots. And that's maybe also interesting to check out here. So it says, if you're looking at all, you can see, so there's the quantum dots with different materials here, I think. With different ways of capping them. So you see here's oleic acid capped, there's fatty acid capped. You can also see there's indium arsenide quantum dot n-type ink, so n-type as in n and p-type, which is usually relevant for doping of semiconductors. There's an n-type ink here as well. So this is indium arsenide, this is with lead. And then there are also other materials. There's a perovskite X-ray scintillator. So that's what I think you need for the detection side of things, I would guess. For the quantum dots. And there is more stuff here. So the idea is that, of course, you have, let's say, access to the raw materials. I would guess that this is interesting for research institution at that point here. But of course, down the road, it might also be interesting for semiconductor manufacturers to get their hands on it. That's why probably we also see that there are some semiconductor manufacturers already in the partner network. And then, of course, from those you derive the chips, right? So these you use to build these quantum dots that then go into the cam. So you can build a camera with them, and then of course you can get that up into applications like adding it to a drone, and then create this business model of let's say mapping or intelligence as a service. So that's like the whole stack integrated all the way from the quantum physics, which is in the materials and the materials manufacturing, all the way up to the intelligence products that literally go into the field. And yeah, I think here we can select. So for X-ray sensors, okay. And we see these parasite crystals and then emitting materials as well. Okay, I think I quickly want to show you the blog post as well, because I think that's interesting as well. Let's take this one because I think it's very explanatory. So here it shows the spectrum. So this is the spectrum for water. And you see there's this 1000. So down here you see the wavelength. And I think this one here is probably the absorption. So you see high absorption means that a lot of light is being taken away, so it's not transparent. And low absorption means the light can just go through. And the wavelength is more or less the color of the light, right? Even though we are here in the 1000 nanometer, 1400 nanometer wavelength, so light is a little bit of a, it's not a visible light, right? But it's still light. And you see here this very sharp peak at 1400. And I think that's what is very interesting. So the 1400, I'm reading from the website, corresponds to what is known as the first overtone of the OH stretching vibration. So HO2 is water, right? And you have this molecule, and now mechanically these molecules, they can vibrate, and the vibration corresponds to an energy, and that energy is kind of related to this electromagnetic absorption. So light is electromagnetic waves. The molecules, they are atoms that are somehow connected to each other by their electrical properties. And if you send an electromagnetic wave, so light, onto these molecules, they can, for example, start to vibrate. And that means they absorb this energy. And that's exactly what you see happening here. And these 1400 then give the first overtone of the OH stretching vibration. And this is then, this vibration level. And that means that, okay, if you can create this light and if you can measure it, if you can create this very selectively, of course you have to be very selective to that frequency, or measure very selective to that frequency, then you can create a detector with that. So detector usually means either you have a light source that can create a lot of different colors, and then you have a filter before your detector. So let's say you have a something that measures light intensity. If you have a bulb that produces a white spectrum, you hold a window in front of it, you see nothing is happening, you take a piece of paper, and then on the detector on the other side you don't see anything anymore. So that's how you can measure broadband. But usually when you're looking at things like this here, you want to have a very fine band. So either you need to create a specific light, and that's usually done, for example, via laser. So a laser light is usually just a very narrow band of wavelength. So for example, you know that from your laser pointer, when you press on it, it shines this red beam. That's only a very specific color of red. So if you're looking at laser pointers, you will see they have all kind of the same color of red. There's no, let's say, red that is a little bit dark, like a little bit more towards, well, infrared you anyways can't see. There's no red that tends more towards yellow. It's always just red. And there's also blue lasers, or blue laser pointers, there are green ones, but it's always the same green. It's not the leafy green, it's this brighter green, right? The same, by the way, used to be true for LEDs. There used to be only very specific ones, and then once you have RGB, you can kind of overlay the different colors and emulate different colors. But long story short is, there are the cases where you have a light source that produces only a specific light specific light frequency or wavelength. And the other thing that you can do is you can have a light source that creates all different colors, like a bulb, for example, and then you take a filter and put it before the detector, so in front of the detector. So like, for example, you take a red filter that only looks at the red color part of the spectrum. And now if you take, I don't know, something that is blue and put it in front of your bulb, then behind the red detector you will not see anything anymore, because you have basically something that is not transparent to anything else than blue in the light path. And that's kind of how it works here as well. So you have these 1400 nanometers that are very specific to water, and then you can, for example, use that for face recognition, because our face is mainly made out of water, because our skin contains a lot of water. And then here it says face recognition is quietly evolving. The first technologies used RGB, so red, green, and blue ranges to detect human face. Then the industry moved to invisible NIR, so near infrared, ranging from 850 to 940 nanometers. It's now used by over 54% of mobile banking apps. However, near infrared range comes with some compromises. And you might know that from your phone. When you unlock the phone, it actually shines a pixel cloud onto your face of this specific near-infrared wavelength here, and then measures back the face that it sees, and that way it can unlock, for example, your banking app. So near-infrared struggles in bright sunlight across varied skin tones and is vulnerable to surface level alterations. This might be considered trivially inconvenient, but when it's supposed to protect your security, not so much. So can, for example, using the sunlight, you might not be able, having the sunlight outside, you might not be able to unlock your phone anymore, or your banking app or whatever. And it's also, not working the same way for different skin colors. Now the proposal here is 1400 nanometer, by contrast, interacts with the unique structure of human tissue with remarkable consistency. Since skin is made up of 60% water, this wavelength is uniquely positioned to enhance the reliability, security, and inclusivity of biometrics. As face recognition becomes more integrated into unlocking phones, banking apps, passport control, it's also entering even higher sensitivity environments like data centers and government facilities, where the cost of failure isn't just in the individual. SWIR imaging offers a leap forward, trustworthy biometric detection. There is also a variables trend, right? So there's more and more variables that you can use to kind of learn something about yourself, to measure stuff on your body. These blood glucose patches. There are also ones for hydration that measure like the skin wetness, like how much you're sweating. And there are also other ones, tissue perfusion, metabolic state. And again, if you can measure water, like how much water is coming from your skin, how much you're sweating, you can kind of access this information better or tune this information better. And there's different cases brought up here, like performance and wellness, clinical and elderly care, population health, and so on. But, and that one I found interesting, there's also industrial cases. So industrial inspection, reducing waste. You see this machine here, which has a lot of potatoes on it. It's a potato sorting machine. And it says, the science is clear. SWIR imaging is the 1000 to 2500 nanometer range, offers a major advantage in detecting industrial moisture-related defects. In potato processing, for example, SWIR models have achieved over 98% accuracy in classifying bruised and healthy potatoes. This significantly outperforms visible and near-infrared systems, particularly for detecting early-stage black spot damage that cannot be seen on the surface. The ability to identify hidden moisture variations has important implications for reducing waste, improving yield, and protecting product quality. This need came through clearly during discussions with a manufacturer for automated sorting equipment. Their challenge is familiar across the industry. Sorting thousands of potatoes per hour, their machines rely on RGB cameras to assess quality. The problem is that RGB can detect surface color, blemishes, and shape, but they cannot reliably tell the difference between harmless marks and internal bruising or rot. As a result, good potatoes are often rejected out of caution in increasing waste. At the same time, defective potatoes can slip through because their defects are hidden beneath the surface, leading to customer complaints and loss of trust. The team expressed a strong interest in technologies like SWIR to overcome these challenges. However, the high cost of traditional SWIR cameras has made broad integration difficult to justify, especially when margins are high. And traditional sensors must prove their value across entire product lines. This is the gap we aim to fill with QCam. Initially developed to demonstrate the imaging readiness of our quantum dot materials, QCam has evolved into a cost-effective, low SWAP module designed to industrial environments. Sensitive from 400 to 1650 nanometers, it provides powerful capabilities for moisture detection, material sorting, and contamination control, making advanced inspection accessible where it can have the greatest impact. And there's more information down here. So this is just to show this is actually interesting for applications, and not just from a science point of view, but possibly also from a price point of view. There is a product already there, so probably very interesting to check out what they are actually doing. With that, I think there's nothing else to mention. That I've seen that they are based in the UK. I don't see much about the team here. What is interesting is there's a shop here, so you can already buy the stuff also from the website. There's a link to the sales as well. I hope you found this interesting. I would be very curious to know if you're more interested in, let's say, learning about quantum computing companies and the quantum software stack, or if also these types of videos that are more, let's say, on the real world application already side, like where quantum already brings advantages, quantum sensors and so on. If this part is more interesting to you, I'd be very curious to know what side of the spectrum you prefer, so I can make videos that you like more. So if you are watching until here, it might be worth dropping a comment below and letting me know. Other than that, I also just wanted to quickly mention, if you haven't subscribed yet, make sure to subscribe. And with that, I let you go for today's video. Thank you so much for watching all the way until the end. Stay hydrated and see you in the next one. Bye bye.